Hi guys, today's lesson is on the inverse sine, cosine, and tangent function. This should be log page 14 in your logbook. Log page 13 should be notes on the Patrick JMT video that you watched on the inverse functions, the basics. Our objectives for today are to find the exact value and the approximate value of the inverse sine function, the inverse cosine function, and the inverse tangent function. Let's recall some properties from the Patrick JMT video of inverses. A function is called one-to-one if it has an inverse that is also a function. Bullet number 2, f inverse of f of x is equal to x for every x in the domain of f of x. This means that any x that I'm allowed to use as an input for the function f, if I input an x into f, I'm going to get an output. That output becomes the input for f inverse. Once that input is put in, the function is applied, and then the output from f inverse is actually the same thing that I started with, x. Bullet number 3. F of f inverse of x is also equal to x for every x in the domain of f inverse. Anything that is allowed to be input into f inverse, when I input that into f inverse, I'm going to get an output. That output becomes the input for f. When that function is applied to it, the output is the same thing that I started with, x. And the last bullet, the graph of f of x and f inverse of x are symmetric with the line y equals x. If any of these points are not clear to you, please go back to the video that Patrick JMT did on inverse functions, the basics, and look at that again. Now, the next thing that I had asked you to do was watch a video from TeacherTube on the inverse trig functions. If you have not watched this video yet, go back to Edmodo and click on this link, or you can highlight this link and copy and paste it into a new tab and watch this video on TeacherTube about the inverse trig functions. And then that will help you to be prepared for what we're going to talk about next. So if you haven't watched this one, pause the video, go watch this video, and then come back. Okay, so hopefully we know now that a one-to-one function is the only kind of function that has an inverse that is also a function. This is the graph of y equals the sine of x, and hopefully you know this function very well. We've been working with it for a long time. Hopefully you know that negative infinity to infinity is the domain of this function. So the domain of this function goes from negative infinity all the way to infinity. And the range of this function is from negative 1 inclusive to 1 inclusive. So this is the range. The range goes from negative 1 to 1. The lowest point on this graph is negative 1. The highest point on this graph is 1. Now the question before us is the sine one-to-one? Well, looking at our horizontal line test, and this can be any horizontal line, y equals any number between negative 1 and 1, the horizontal line test shows us that this is not one-to-one. So no, the sine is not one-to-one. The sine is not one-to-one. We talked about or looked at in the previous video how to restrict the domain. Y equals the sine of x. In that video we discovered that we were going to restrict the domain for the sine of x from negative pi over 2 to pi over 2. So the restricted domain for the sine of x is negative pi over 2 to pi over 2 inclusive. This is your restricted domain. Because once we have restricted this domain, my function is now 1 to 1. I could put vertical line test anywhere between -1 and 1 and see that we're only going to be touching one point at a time. What does the inverse sine of x really mean? Well, y equals the inverse sine of x, that's this notation right here, means that x equals the sine of y. Y here is an angle. This is crucial for you to understand. Okay, y equals the sine inverse of x. Y is an angle. We are looking for an angle when we are given a value for the sine of the angle. So we're given the value for the sine, and we are asked to find the angle. Now, we're going to do this for this restricted domain. So we're only looking between negative pi halves and pi halves. And our x, this value for sine, is always going to be between -1 and 1 inclusive. Now there's a difference between how we read something and what it actually means. We read this as y is the inverse sine of x. But what this means is y is the angle, okay, this y right here is an angle or a real number whose sine is x. So this x is the value for the sine, and this y is an angle. We seek an angle here. Now, the sine inverse and the sine, those two functions will undo each other. So the sine of u, if I do the sine inverse of the sine of u, I'm going to get what I started with, as long as my u is in the restricted domain for the sine. And the sine of the sine inverse of v is going to equal v, what I started with, as long as v is between -1 and 1. This is very important. Okay, this is only true in this restricted domain. This is only true between -1 and 1 inclusive. Okay, the characteristics of the sine inverse. Okay, the domain of the sine inverse is the range of the sine. Because they are inverse functions, the domain of the inverse is the range of the sine, and the range of the inverse is the domain of the sine. So since we already know our restricted domain is negative pi halves to pi halves, then the range of the sine inverse, the angle that we're looking for, is going to be an angle between negative pi halves and pi halves. Okay, here's the picture, the graph. Now we've already looked at y equals the sine of x. That's our pink graph right here. This is the sine function with the restricted domain from negative pi halves to pi halves. The blue function is our sine inverse. Now notice that it's reflecting across y equals x, and notice what's happened to the x and y values. Pi halves 1 is a point on the sine function. So to get the point on the inverse function, we just switch x and y. So now we have the point 1 pi halves. If 1 is the value of the sine, the angle that has that value is pi over 2. And the same here for the point on the function negative pi halves -1. We switch x and y and get -1 negative pi halves. When we switch this point right here, 0, 0, we still get 0, 0. All right, now we're going to look at an example of how to find the exact value of y equals the sine inverse of the square root of 3 over 2. The first thing I want you to notice here is that I could rewrite this instead of a y with a theta. And I do this because I want to remember that what I'm looking for here is an angle. This is what I want to be sure that I'm understanding, is that when I see the sine inverse, I am looking for or seeking an angle theta between negative pi halves and pi halves inclusive, whose sine is the square root of 3 over 2. That is what this is asking me to do. Look for an angle between negative pi halves and pi halves, that's our restricted domain, whose sine is the square root of 3 over 2. This is the value of the sine. This is the angle that we seek. Now, I could go straight to my calculator. However, I don't even need to do that because I know that the square root of 3 over 2 is a value that's on my unit circle. It's positive. And if I'm looking at my unit circle, between pi halves this way and negative pi halves this way, I'm looking for the angle who has a sine of positive square root of 3 over 2. Well, I know that all trig functions are positive here, and the cosine and its reciprocal are positive here, so I know I have to be in quadrant 1. So my angle has to be here in quadrant 1. And the angle in quadrant 1 that has a sine of the square root of 3 over 2 is pi over 3. So I should be able to look at these, know what it asks me, and answer the question. Okay, so let's look at this one. Find the exact value of y equals the sine inverse of the negative square root of 2 over 2. Well, what I'm looking for here, again, I'm going to change my y to a theta so that I do not forget that I am looking for an angle. Anytime I see the sine inverse of a value and I'm looking for what it equals, I am looking for an angle between pi halves and negative pi halves inclusive, whose sine is negative square root of 2 over 2. Well, again, I know that the only place I can look is between pi halves and negative pi halves. And I'm now looking for a sine who's negative. All trig functions are positive here, so I know I have to look down here in quadrant 4. And since it has to be a negative angle in quadrant 4, then I know that I'm looking for negative pi over 4. Please understand that the only place you can find the sine inverse is quadrant 1 and quadrant 4. In quadrant 1, your value of sine is positive, and in quadrant 4, your value of sine is negative. Okay, the value of the sine is negative. In quadrant 1, your angles will be positive because we're going to go in our counterclockwise direction. In quadrant 4, your angles will be negative. We're not going to go all the way around. We're going to go in a clockwise direction in quadrant 4. We are not going all the way around here to 3 pi over 2. We're going in a clockwise direction. So whenever I'm in quadrant 4 and finding the sine inverse, my angles will be negative. Whenever I'm in quadrant 1, my angles will be positive. And those are the only two quadrants that you are allowed to look in because we have restricted the domain from negative pi over 2 to pi over 2. Okay, this is the end of this video, and then the next video will be on the cosine.